Today maximum will do the problems on first law of thermodynamics. So maximum problems are first law of thermodynamics only. The question number 1, very simple. This is the simple and logic. So already yesterday in previous class, I'll explain about the process. So this is the table is very important to solve the problem related to thermodynamics. Means they can ask the Q value, or they can ask only dW, or that means work done. These two only they will ask the question. It depends on the given graph and process, which process that you have to follow. In isobaric, the work done equal to NR delta T, and here the Q is equal to NCP delta T. Also I can write already Q. This is dQ is equal to NCP delta T. You can see Q is equal to du plus dW, NCV delta T plus NR delta T. So CV plus R, CV plus R. That means CP, NCP delta T. So whatever the process, if it is isothermal, internal energy is equal to 0. The formula is nRT into Vf by Vi ln, and dQ, heat energy and work done both are same in isothermal. Whereas adiabatic heat energy is 0, and du is equal NCV delta T is equal to minus of P1 V1 minus P2 V2 by gamma minus 1. du is equal to minus, means these two are equal and minus sign will come. So in cyclic process, du is equal to 0. That means work done net is equal to sum of all work done in cyclic process in the given graph, and Q net also sum of the Q of all processes. So this is table. Remember this. Isobaric is given, isochoric is given, thermal or adiabatic. Depends on asking. Work done means this formula. Or here this can be nRT into NR. This is also equal to NR into T2 minus T1 by 1 minus gamma, or NR into T1. P1 V1 equal to NR T1 minus NR T2 by 1 minus gamma, or T1 T2 is coming means gamma minus 1. So this is formula. Depends on given temperatures are given me, this is value, pressure and volumes are given me, this value, this formula. And here P1 P2, to calculate the P1 P2, P1 V1 is N1 NRT1 should not take. To find out the P1 P2 from given V1 V2 and any one of the P value, we have to use P1 V power gamma equal to constant, or we know T V power gamma minus 1 is equal to constant, or P power 1 minus gamma into T power gamma is equal to constant. So these formulas you have to use to find out the relation between P and T, T and V, P and V. Those values of P2 or V2 will substitute in this formula. So that related problems I will explain now. See. So first problem, dQ is given 735 joules, means heat energy given. First. And gamma, ratio of specific heat 7 by 5, means diatomic gas is given. And expanded constant pressure is given. So it is an isobaric process. So asking to find out du, means internal energy is how much? Because already NCP delta T they have given. In isobaric means this dQ is equal to NCP delta T they have given. Asking to find out du NCP delta T. So this is the question related to gamma is Cp by Cv. Cp value is given here NCP delta T. Asking to find out NCP delta T. It is not purely related to only first law thermodynamics. Related to Cp by Cv values also. So here NCP delta T is equal to 735 joules. So now NCV delta T is asking to find out. So from this N delta T find out. The Cp is equal to here 7R by 2, we know. That equal to 735 into 2 by 7R. Cp bring this. Now NCV delta T I1. du is equal to NCV delta T. So substitute N delta T value. This is N delta T value into Cv. Cv is equal to 5R by 2 for diatomic. Here it is given diatomic. 7 by 5 is diatomic. So get the answer. So now work done also you can find out here. Therefore dQ is equal to 735 and du is equal to 525. Then dW is equal to dQ minus du, 735, 525 minus of 525. So this is the work done. but you are not asked that, so you can try. And next question is given the gas expand adiabatically, and the volume is changing from 8 liters to 27 liters. Liters are given. So if you want needed to convert means that convert into meter cube, otherwise no need. So gas expand adiabatically from 8 liters to 27 liters. So adiabatically is given. So immediately have to get the relation between PV power gamma or TV power gamma minus 1. Those three formulas you have to remember. Because here we don't know which is asking. Is asking gamma value is equal to question mark. And the ratio of the pressures P2 by P1 is given 16 by 81. So the ratio is given P2 by P1 and V2, V1 values are given. From the given value to find out the gamma, I am choosing this formula. The choice of formula is this one only ultimate. There is no other way. So ultimate formula is this one. So now coming into, so we know from this P2 by P1 equal to V1 by V2 whole power gamma. So now P2 by P1 is given and V2 by V1 will substitute, means V1 by V2. P2 by P1 equal to V1 by V2. So both the sides convert 2 by 3, 2 by 3. So gamma equal 4 by 3. This is very easy formula. So they have given adiabatical expand. On this similar formulas I will explain, you know. Adiabatic expand adiabatically. See here compressed adiabatically is given. A diatomic ideal gas. So here given diatomic. So then gamma is equal to 7 by 5, that equal to 1.4 to 1 by 32 of its initial volume, means V2 is equal to V by 32. The initial temperature of the gas is T1. So T1 is initial temperature. Then asking final temperature is equal to question mark T2. They are given which is equal to N into T1. Then N value is how much? This is the question they are asking. So now this one here given is V2 T1 is given, T2 is asking. Means V2 V1 relation is given. Therefore automatically here the formula is T into V power gamma minus 1 is equal to constant, that equal T1 V1 power gamma minus 1 is equal to T2 V2 gamma minus 1. Therefore T1 by T2 is equal to V2 by V1. V2 is equal to V by 32 into V. Gamma minus 1. Gamma equal to, for diatomic, 7 by 5. So that will be 7 by 5 minus 1 means 2 by 5. So therefore T1 is T1 only. Then T2 is equal to T1 into V, we get cancelled. 32 whole power 2 by 5. So this 32 I can write 2 power 5. 2 keep 2 power 4. Yeah, 2 power 5 I can write. 5 get cancelled. 2 square. Therefore 4 T1. 4 T2 is equal to 4 T1. So next model of the problem. An adiabatic only first will complete. So here see, calculate the work done. Is asking work done. dW is equal to question mark. In adiabatically, dW is equal to nr T2 minus T1 by 1 minus gamma, or P2 V2 minus the P1 V1 by 1 minus gamma. If you want to take P1 V1 means gamma minus 1 will come. Right, this is. In 1 mole of gas is given, N is given, N is equal to 1 mole. Compressed adiabatically. The initial pressure and volumes are given. So this is only formula. So initial pressure P1 is equal to 10 power 5. The V1 is equal to 6 liters. So that I can write 6 into 10 power minus 3 meter cube I can write. And the final value V2 is given 2 liters. That equal 2 into 10 power minus 3 meter cube I can write. Because already liters how to change, yesterday I have given, I think so. In means in last video I have given. Because 1 liter is equal to 1000 mLs. 1 ml equal to 1 cc, that equal to 1000 into cc means 10 power minus 6 meter cube. That equal to 1 liter equal to 10 power minus 3 meter cube. This conversion you can use. Right. Now here the work done means P2 I don't know. To find out PV2, this is adiabatic compression, right? The P1 V1 power gamma is equal to P2 V2 power gamma then P2 is equal to P1 into V1 by V2 whole power gamma. So here gamma, to find out the gamma value here given, the constant value 3R 2 by 2. The specific heat of constant value 3R by 2. That means monoatomic gas. So it is indicating monoatomic gas. So the gamma value is equal 5 by 3 will come. That equal 10 power 5 into V1 by V2. So 3 into 5 by 3. So 3 into 5 by 3 will become 6.26. If you calculate, that will be 6.26. P2 I got. Now is asking the work done. Therefore dW is equal to P2 V2. That means 10 power 5 into 626 minus means P2 into V2. V2 is 2 minus P1 V1. 10 power 5 into 6. So by it is gamma minus 1. That is 5 by 3 minus 1. 2 by 3. That equal to 3 by 2. So now 10 power 5. Here 2 liters said this is 2 and 6 liters. 10 power minus 3. 10 square into. So now 6.26 multiplication. 12.52 minus 18 by 2. You get the answer, right? Something. Here and work done is minus is coming because compression, right? Compression. So therefore minus 5.48. Am I correct? 5.48 by 2 into 100. So that equal to 2 4 ja, sorry, 2 2 ja, 2 sevens, 2 fours, 274. In 274 joules minus 274. A small mistake came. That is, here this is 3 by 2 is like this. So now 10 power 5 into 10 square, 12.26 minus 6 into 3 by 2. So now if you do this one, means 6.26 again, means 626 by 2 into 3. That equal to 313 into 3. So 9 3 means 3 is 9, 939 joules. So this is answer. And this is minus work done. Minus work done y means compression, right? So here 1 minus gamma means 1 minus 5 by 3, that equal to minus 2 by 3 will come. The work done will be minus will come. Here 1 minus gamma is there. So work done is minus. You understand? Means this 3 by 3 power 5 by 3 I have taken 6.26. So this value is correct, I think so. So I am getting this value. Right. In adiabatic, one more problem I will find out. So it is not adiabatic. Right. Next, here see one problem. So gas adiabatically expands here, same. But in this case, 8 to 27 liters. That means it is compressed here, but here expands. Okay, 8 to 27 means compression only. Here also V2 to 2V1 expansion. Sorry, expansion. Expand adiabatically 8 to 27. So V1 is 8, V2 is 27. Similarly, here V2 is equal to 2V1, so expands only. Asking to find out work done is how much. So here work done in adiabatical case, NR T2 minus T1 by gamma minus 1 R. I can go with the P2 V2 minus P1 V1 by 1 minus gamma. P1 V1 minus P2 V2 by gamma minus 1. However, you can take. So now here V relation is given. Either you can use this one or this one, not a problem at all. And you can go here. Formula between T V1. I solve like this because answer is given in T. The answer is we have to bring in T's. That's why I'll go with T1 V1 power gamma minus 1 equal to T2 V2 power gamma minus 1. So as usual, T1 by T2. This is. And here gamma value is given 3 by 2. That means monoatomic is mentioned. So then gamma equal to 3 by 2 is a given value. So then 3 by 2 minus 1, 1 by 2. Therefore T1 by T2 equal to 2, T1 equal to root 2 into T2. Therefore now W is equal to, so here is N value also 1 mole of gas. Since N is equal to 1 mole of gas consider. Otherwise, NR keep like that, not a problem. So R by 3 by 2 minus 1, gamma minus 1, that equal to 1 by 2 will come, that 2 will go up. R and T2, T1 plus root 2 into T2, T2 take common. Therefore, R T2 into 2, this denominator 2 will come, 1 minus root 2. Therefore, RT into 2 minus root 2 minus 2, work done. So, if in terms of T1, if I want to write means, substitute here, the RT T2 is equal to T by root 2. So, that equal to, in the place of, I will get answer here that equal to R root 2 into 1 minus root 2. So, this is equal to RT into root 2 minus 2. So, this is RT2, 2 minus root 2. In the terms of T, if T2 I want to write, T by root 2. So, here T root 2 will come, right? RT into root 2. So, this is answer. So, now another question. So, graphical question is given here. So, this is P0 and T0 point. I mean, this is also B is 0 here, T is minus. The P is 0, T minus T comma 0 point. P is 0. And given slope, the slope of PT graph is P and T comma slope of PT graph. That means P by T I want, P by T is equal to NR by V. So, it shows 1 by V. Otherwise, PV is equal to NR by V into T. So, here T is T plus 2, T is Kelvin temperature. Therefore, in degree centigrade, T plus 273 I can take, that is in degree centigrade. So, here the ideal gas equation T is equal to Kelvins. The temperature is Kelvins. But here in the graph is given T is equal to T degree centigrade. Therefore, the T I can write T plus 273. So, if we come to this point at K point, pressure is equal to 0. Then automatically T value in minus, that equal to minus 273. Very simple question this is. But when you are seeing this graph, after knowing the solution, it will become very easy. But initially, these 2 points you have to take it. These 2 points, understanding the graph, these 2 points over. Now coming into next question. A sample of ideal gas is taken through cyclic process. Cyclic process is mentioned. So therefore, du is equal to 0. In that, no doubt at all. Du equal to 0 means dq is equal to dw here meaning. That means in already I said sigma q is equal to sigma w. So in cyclic process, sigma q is equal to sigma w. Therefore, sigma q 40 joules of heat energy absorbed and released 60. Therefore, 40 is plus 60 is minus. This is net heat energy. So sigma q is equal to here minus 20 joules is coming. So if you see 40 joules is absorbed and 60 joules is, so this is right with initial internal energy. We no need of internal energy concept here because it is anyhow 0. Whatever the value of internal energy at A is given, that is out of matter, no need for us. Whatever they can give, but total internal in the cyclic process, total internal energy is 0. So now the work done is 50. Work done is 50 joules during the part BC. Here part BC work done is given. And now work done during the part CA is asking here. Sigma W is equal to, is asking to find. So this is in cyclic process, du is equal to 0, Q is equal to Q net, sigma Q is equal to sigma W. So now this is the answer will come. And if you see here cyclic process very clear, anti-clockwise direction. This is anti-clockwise direction. Therefore, negative energy. The work done is negative joules. So now here graph is not given in this question. A gas can be taken from A to B via 2 different process. So like this. So A, C, B is one path and ADB is another path. Means ACB is one process, cyclic process, not cyclic process, that is the only process. So in previous video, I explained what is state, what is path, what is process, what is cycle, right? This is only series of path is called cycle only, not cyclic process. It's the process only. 2 processes are there here. So now ACB, that means if this ABCD is a cyclic process, if we consider, then du is equal to 0. That means the du along ACB is equal to du along ADB. The internal energy along ACB is equal to internal energy along ADB. So internal energy means dq minus dw. dq minus dw along a db. So that implies, so here given 60 minus 30 is along ACB, again by the system along ACB, is equal to the work done in any ADB system is 10 joules. Then heat flow is asking. Therefore, work done, therefore dq minus 10. dq minus 10 joules is equal to question mark. So dq I want to find out. Therefore, 30 plus 10 is equal to dq. Then dq is equal to 40 joules. So this is answer correct. So next model, next question. 3 moles of N value is given here. N is equal to 3 moles. And ideal gas is mentioned. Cp is equal to 7R/2. So automatically it is a diatom. Because Cp is equal to 7R/2 mentioned. Then Cv is equal to 5R/2. And gamma is equal to 7/5, 1.4. So from the given data, that is isothermally expanded to the twice its initial volume. Therefore, V2 is equal to 2V, V1. Then isothermally expand means dW is equal to nRT into ln of V2 by V1, the work done. So that equal to nRT into log 2 will come, ln2 will come, that equal 0.693. So this is equation 1. It's then compressed at a constant pressure to its original value. That means here we have to go with the diagram. Consider here. So initially V1 is there, expanded to V2. By keeping the isothermal expansion means temperature is constant. V1 to V2. If you take temperature constant means, so here this I will take TB. By keeping the temperature constant, it expands like this. So now it compressed at constant pressure to its original value. Finally, the gas compressed at constant value means here see from the given, then compressed at constant pressure. So here it is take PB and it is PA. So now the graph will be like this. First I will take PA to PB, VB isothermally expands. PV graph for isothermal expansion I have taken like this. This is PA and VA, PB and VB. Then at the constant pressure, it is compressed to original value. So this is the way compressed. So isobaric process. So now take this is point A, point B and point C. Now finally the gas compressed to initial pressure constant value. This is the graph will come. So you can change value and this one and here temperature also you can take, not a problem, temperature and value. So TA and TB. So volume and PV graph is clear. This is so like this. First expands isothermally, therefore work done came. Then here it is isobaric. So the work done in isobaric process is equal to NR delta T. That means NR into T2 minus T1. So here T2 minus T1 I don't have the values of T2 minus T1. I need to find out the T2 minus T1 value. Here T2 T1 don't know. That's why P into dV I can take, right? PB into dV. That means VB minus VA. So that equal to PB I don't know here and it is given ideal gas. So therefore P1 V1 is equal to P2 V2. So that equal to PB into 2V1. Therefore PB is equal to P1 by 2 or PA by 2. So that I can write here PA by 2 into VB. That means V minus 2V. So that equal to minus of, because here compressed, right? Minus only work done. In that no doubt at all. That equal to PAV by 2. Pressure into volume by 2. So here PAV, ideal gas equation again, that equal to, I can write here it is minus NR TA by 2. Because answer is asking into NTA. So this is equation 2. Now asking here the total work done, the net work done and heat supplied to the gas. Both are equal only here because it's a cyclic process. Therefore sigma dq is equal to sigma dw. That implies sigma dw is equal to sum of this one nRTA into 0.693 minus nRTA by 2. So take common nRTA. So that equal to 6, 0.786 minus 1, 786. Good number. So here 3 moles of gas is given 3 and R value 8.314 into 4 subtracting 1 means 0.004, 1 and 2, 0.214. So this you calculate, you will get answer. So that will be the 1 minute. 4.81 joules has to come. 4.81 joules. This is the answer after calculation. So I hope understand this process. Means graphical representation. We can go with T and V or T and P time also. So here isothermal T is constant, initial expands. For example, see. So this is V1 consider and V2. So it is V1 to V2 increased. Then compressed at constant pressure to its original value. It compressed it to. So here T and P we can go. T and V not possible because it compressed to original value at constant pressure means here pressure has to be compulsory. So this is the P we have to take then. PT graph we can go. So in PT graph, so now P1, P2 and this is T1, T2. So it expand. So here I am confusing it, converting into this one. At constant temperature, isothermal expansion this is. So at constant pressure, it reaching the original volume. This is the original volume, constant pressure. So where the pressure is constant for ideal gas, the V proportional to T. Therefore, V by T, the slope of VT graph is equal to NR by P. So slope of PT graph, right? VT. So like this, yeah. It is compressed to original volume. So now the pressure is constant. This is the pressure value. T by V is equal to P will come. The slope of this graph is equal to T by V. So now again it is come to original state. At constant volume V1, it will be reach it to right. So now here it is cyclic process. Here it is anti-clockwise. Both are cyclic process, clockwise and anti-clockwise. This I hope understand. The graph for T and V. So this is. So I try to give the clarity how to draw the PV graph into TV graph. Right. Now coming into here, in this problem, CP value is given 5R by 2. CP value 5R by 2 means it is a monatomic gas indirectly. Monatomic gas. Then gamma is equal to 5 by 3. The gas is kept at closed vessel. Remember this closed vessel. The V is constant, that equals 0.0083 meter cube. That means constant value. At a temperature T1 is equal to 300 Kelvin. And pressure P is equal to 1.6 into 10 to the power of 6. Pressure means Newton by meter square. So amount of heat energy also given. Therefore Q is equal to 2.49 into 10 to the power of 4 joules. It's applied to the gases. The final temperature is asking. So T2 is equal to question mark. So if you see here volume is constant, pressure is given 1.6. When heat energy is supplied to the substance, then temperature is rises. And pressure also rises, right? Pressure also changes. That means at constant volume, the variable terms are P and T. So therefore, I have to find out here relation between PT. Is the problem here. So that is. So here see diagram. So shown in the figure is given. So figure is like this. So cyclic process. So this is A, B, C, D. So clockwise cyclic process it is. And here Pa is equal to 1 atmosphere. And this PV is equal to 2 atmosphere. This is Va. In Ta, this is 300 kelvins, not Va. PT graph is equal to PT graph is given 400 kelvins. So I'm asking heat energy in joules is asking. Therefore, the cyclic process already we know and it is clockwise positive. Therefore, EQ is equal to E into W. That means W of AB plus W of BC plus W of CD plus W of DA. So work done. DQ is equal to work done. In this case, DU is equal to 0. So now coming into work done AB. So A to B is work done of A to B AB process. The AB process is isothermal expansion. It is isothermal expansion. That means nRT into, so this is not expansion, isothermal expansion is not, because at constant temperature pressure is increasing along AB. So pressure increases according to Boyle's law, volume decreases. So this is isothermal compression. So nRT into, here we will get clarity, nRT into, so actually isothermal process will go with Vf by Vi, but here P1 by P2, Pa by Pb, that equal to 1 by 2. So this I can write minus nRTA into Ln2 I can write. So that is equal answer. N means here 2 moles is given. R means 8.314 into Ta is equal to 300. Ln of 2 is equal 0.693. Otherwise log means 0.3. That you can take, not a problem. So this is one work done came. So coming into next, work done from BC. Work done from B to C. So it is clear, it is isobaric process. This is what? Isobaric. Because pressure is constant. Therefore 2 into here to here. That is Vc minus, means here it is temperature increasing. So that I can write Vc minus Vb. So this will be Nr into 400 minus 300. So it will be equation 2. So here Vc, according to ideal gas equation, this gas is ideal gas. It means helium gas also behave like ideal here. Therefore P is constant now. Then V1 by T1 means V is equal to Nr by P into Tc, temperature at C. So Vb is equal to Nr by P into Tv. So now I will write here Nr into Pp get cancelled, 2 get cancelled here, Nr by 2. Therefore Vb minus Vc or Vc minus Vb is equal to Nr by P into Tb minus Tc. But here I want P into Vc minus Vb, substitute means Nr into T2 minus T1. That is also work done from BC in isobaric process, Nr delta T, Nr into T2 minus T1, or P into dV, work done formula. So now work done from C to D. So this is also isothermal. Here it is isothermal expansion. Okay. If AB is isothermal compression means compressor CD is isothermal expansion, that is equal to Nr Tc or Td. Both are same only. At T and D temperature is same. Therefore Ln of, here P's are given and therefore P1 by P2. That is Pc by Pd. That equal 2 by 1. So that equal again Nr into 400 into 0.69. So equation 3. So now work done from D to A. So that equal to, so same pressure 1 atmosphere into Va minus Vd. It is a compression, so negative work done. So that is how much? Nr into minus of Nr into means 400 minus means 300 minus 400. So this is minus work will come. So you don't need to take again minus here, because already why minus work is the minus work means because compression, right? That means temperature is decreasing 400 to this one. The volume also decreases. So that's why this is minus of. So 2 and 4 cancels each other. That is how much work done is equal to total heat energy Q is equal to total work done. That equal to 1 plus 3. That means 1 minus 3 or 3 minus 1. That equal 3 minus 1 will go. This is 400. So therefore 2 into 8.314 in joules they're asking, not calories. In calories means this will be 2. R value 2 will take. Sometimes they'll ask in calories. So joules they're asking, we have to go with 4 means 2 calories for heat energy. But here joules is asking, so 8.314 into ln2 0.693. So here 3 minus is 300 plus is 400. Therefore 400 minus 300 100. So that is equal to, so 28. This is all means you'll get answer. That answer is correct. So in that no doubt at all. So I hope this understand, right? So answer will be 11.525 will come. So that is 11.53 joules. So this is answer. So now coming into next question. Given diatomic gas is given. The R is equal to 7 by 5. Does the work means dW is given. So that is equal to 400 joules. When it expand isobarically. So then dW is equal to nRT2. The heat energy given in this process. So therefore, in this isobaric process, here is asking dq. dq is equal to du plus dw. So here du value we have to find out. dw is already given. Du value you have to find out. To find du, ncv, du is equal to in all the process ncv delta t. So that equal to n means diatomic gas is given. Here I want cv delta t value. So that equal to n into cv. Diatomic is given already. So 5r by 2 into delta t. So that equal to nr delta t into 5 by 2. But I don't know nr delta t is how much. And it is isobarically. Therefore, in isobaric process, nr into delta t is equal to dw. So that equal to 400 joules. That is equal to 400 into 5 by 2. That equal to 1000 joules. So here it is very clear how it is came nr delta t means. In the table anyhow I have given. But again here I will explain. See, dw is equal to pdv. Isobaric means pressure is constant. V2 minus V1. That equal to P into V equal to nr by P into T2 V2 minus nr T1 by nr T1 by P. For the P get cancelled. So nr into delta T. So this is the work done in isobarical process. So now the total dq is asking. Heat energy is equal to dw plus du 1000. So that equal to 1400 joules. This is correct answer. So another model of the problem. See. So next question. Given that 1 mole of ideal gas is given. So n is equal to 1 mole and ideal gas. Ideal gas means PV is equal to nr into delta T or nRT. Where pressure and volume, the obey the relation, the P is equal to P naught into 1 minus 1 by 2 into V naught by V whole square. So P and V naught are constant, V is changing and P value also changes. Means P and V how they are changing they have given. So now the change in temperature of the gas, the volume changes from V naught to V. The change in temperature that is equal to T2 minus T1 is equal to how much? So where volume is changing V naught to V naught. So at V means T2 is equal to, according to ideal gas equation I can write PV by nr. P2 V2 by nr. T1 is equal to P1 V1 by nr. Correct? So now T2 minus T1 I want. Therefore here P is equal to the P1 at V1 is equal to P naught into 1 minus 1 by 2 into 1 whole square. So V is equal to V naught. That is equal to P naught by 2 will come. So this is P1. So now similarly P2 is equal to P naught into 1 minus 1 by 2 into V equal 2 V naught is substituted means 1 by 2 whole square. So that is equal to P naught into 1 minus 1 by 1 by 8 means 1 by 8. So 7 by 8, 7 P naught by 8 P2. Therefore, delta T is equal to P2 V2, right? T2 minus T1, P2 V2, that is equal to 7 P naught and V2 value 2 V naught by 8 minus P1 V1, P naught by 2 into V naught. So now 8 LCM will come. 8 is the LCM into NR also is there here. NR and NR. So we can write NR. This is 8 NR is the LCM. Therefore, 14 P naught V naught minus the 4 P naught and V naught. Right? That is equal to 10 P naught V naught by 8 NR. So now this is, I can write 5 P naught V naught by 8 NR. So this is change in temperature. So similarly, you can try another model. For example, so here 5 P naught V naught by 4 NR. Right. So next model. So 1 mole of ideal monoatomic gas. 1 mole N is equal to given 1 mole. And monoatomic gas, that means gamma is equal to 5 by 3. Cp is equal to 5R by 2. Cv is equal to NR by 2. Because whenever you want to substitute, is taken along the path. They are given the diagram like this. So this is 3 P naught and P naught. So it is taken by cyclic path. So like this. A, B, C, A path. This is the path. And this is the graph PV graph. This is 3 P naught, P naught, and V naught, 2 V naught. Monoatomic gas, 1 mole of gas is taken. Now is asking the maximum temperature attained by the gas along the path BC is given by. So here temperature is equal to how much? So in this calculation, to find out the temperature, so again ideal gas equation. This is a monoatomic gas, ideal monoatomic gas. Therefore PV is equal to NR. PV is equal to NR into T. Then T is equal to PV by NR. So along this line PV, I have to relation between the P and V I have to find out. So finding, so point B, the B points you take, those are V naught comma 3 P naught, and the C point you take, that is 2 V naught comma P naught. So those are the values of B points and C coordinates. Now this is B represents here this point and C this is the point. These are the B and C are states we'll call now. BC is the change in V naught to 2 V naught, 3 P naught into P naught is path, and process here this is PV, the slope of PV. So slope of PV is not given any thing. So multiplication of PV only there. Okay, we'll see this. So now equation write down. So we know how to write the equation. So that equal to, when 2 points are given, y minus y1 is equal to y2 minus y1 by slope into x2 minus x1 into x minus x1. Here x is equal to v, y equal to p. PV relation I want to. Therefore p minus p1 means point B. BC equation I am finding. It is opposite means CBV equation will come. So p minus p1 means x1 y1 3 p naught is equal to y2 minus y1. y2 minus y1 means pressure. So that equal to minus 2 P naught by x2 minus x1 V naught into V naught V minus, so V minus V naught. So if you go like this time takes, I will complete the process and I will come to explain. Now see. So after equation we will get P equal to 5 P naught minus 3 P naught V by V naught after writing the equation. So now this P substitute in T value. T is equal to PV by NR, right? So I got P value 5 P naught minus 2 P naught V by V into V by NR. P value only substituting, P value in terms of V is the variable pressure. Pressure is varying with respect to V in this equation. Now we are multiplying V inside, that equal 5 V naught V by NR minus 2 P naught V square by V naught into NR. Now is asking T maximum. So in NLM and work power energy, wherever, whatever the quantity is asking maximum means, dt by maximum or minimum means its derivation is equal to 0. And here derivation with respect to here variable in this equation is equal to V only the variable. P naught, NR are constant, right? V naught, P naught, N and R are constants. Therefore, only V is variable. Therefore, dt by dV is equal to 0. So now there V is equal to, we get 5 V naught by 4. Asking T value, right? Therefore, substitute this V value in the T here, in this equation or in this equation, whatever. So now I am substituting 5 P naught minus 2 P naught into V value 5 V naught by 4 V naught, V naught get cancelled into V by NR, 5 V naught by 4 by NR. So answer will come this one. So like that, depends on the given equation, given process. So here is asking the maximum temperature in this case. So line equation, P slope is there means you can find out temperature value. But area under this graph, PV is equal to nRT. The area of this graph is equal to P into dV. Right? P2 minus PV into dV. That is equal to NR. Like that also you can find out. But here variable P is given. That is PV equal to nRT, T equal to P by NR, where PV all are constant, right? Given value of P, given value of P. But given value of P is variable is given, right? So it's varying with the relation is coming, right? P is relating 5 P naught minus 2 P naught by V naught into V, variable V. So here P naught and V naught are constants, right? Initial values, they have given the value P naught and 3 P naught values. On constant only have to take. So I hope like this is one model. So like this, there are another models are there that I will try in explanation in another video, right? Thank you.